Welcome to the Confidence Through Health podcast. My name is Jerry Snyder. As a health, wellness, and sports performance coach, my goal each week is to bring you experts to help you take control of your health and build your self-confidence. Thanks for including me today on your journey to better health. I'd like to thank our sponsor for this episode, All In Health and Wellness. If you're looking for a health coach, you're looking for a sports performance coach, you're looking for nutrition guidance, like for instance, a meal-by-meal plan that will help you understand how to eat. It will teach you how to eat, and it will give your body, your cells, the proper nutrition to feel great and be able to perform at your best, not just physically, but also emotionally and mentally. If you're looking for those things, you're looking for the key to improve your sports performance, both from a nutrition standpoint and an exercise physical standpoint and a mental standpoint as you approach your athletic event. All In Health and Wellness is able to help in these areas. Go to allinhealthandwellness.com and you'll find the contact information for how to get in touch with them and get started on the plan that will improve your life. Well, thank you, Dr. Wanek, for being a guest on the Confidence Through Health podcast.
You're welcome. Happy to be here today.
And one of the things that really sparked, like, when I look at what my own health journey and my own health, like, passion and knowledge and wanting to help people has evolved to, I've got my degree in exercise physiology, but I don't have the medical degree or the further on, education. It's all been my own, just taking little courses here and there and learning from people that are what I call the experts in what I believe is true health and medicine. And what I love is that you bring the actual MD in a lot of the things you say. And I'm like, she's validating what I say. She's validating all these things from the stuff that you've seen in your practice and in working with all these people. And so before we get into that, I know that you started out as a pediatric surgeon and then transitioned to a little bit more of the functional medicine, holistic medicine type of atmosphere. Like,
Yes.
what sparked that change?
Well, I guess it started way back, actually, when I got my undergraduate degree in chemistry.
Mhm.
And then I went on to train as a general surgeon and pediatric surgeon. And at the time, I was also an athlete, certainly not at your level, but
Yeah.
I was playing club racquetball probably at least 5 days a week.
Yeah.
I was, in my age group, very competitive at the time. I play golf, and I've been in USGA mid-amateur and senior
nice.
amateur championships.
Awesome.
So I've really been athletic all my life, and yet I was training in a gym at least 5 days a week, lifting weights, doing circuit training,
Yeah.
carbo loading.
Right.
Which was, what the rage was back then.
Yeah.
I was hungry all the time. I was tired all the time.
Yeah.
And I was strong. I was really strong, but my body fat wasn't changing. And
Right.
so when I was about 40 years old, studying for my surgical boards, I happened to go to a Women's Sports Foundation banquet in New York. And I talked to one of the 4x100 athletes, and I just asked her, I said, what do you eat? I was curious.
Yeah.
And she said, well, have you ever heard of the Zone? And I said, no, I haven't heard of it. And so I got the book. It's called Enter the Zone by Barry Sears. I don't know if you've heard of it or not.
Yeah.
But as I went through it, it's nutritional biochemistry. And as I'm reading this book, well, I didn't think this had anything to do with me. I just thought it had to do with weaning patients off of ventilators and giving people parenteral nutrition if they couldn't eat by mouth, or giving them IV nutrition. But I never personally made the connection between how my body was working relative to how I was feeding it.
Yeah.
So I started eating in the Zone, and immediately I felt better. I was actually still exercising 5 days a week, but eating less and having to do less reps, and had better endurance. So I this was probably within a month of making these changes. So I wanted to know more. I wanted to figure out why this was all happening and know what was going on. And I was at a segue in my own professional life, and I decided that I was going to start teaching people how to eat in the zone.
Yeah.
And that sort of led to taking the first functional medicine course in Gig Harbor, Washington in 1998. This was developed by a nutritional biochemist, Jeff Bland, who was giving doctors nutritional medicine updates by tape recording at the time.
Oh, wow.
So I went through that class and I learned a lot. But something kept bothering me. It was like, well, inflammation is the root cause of disease.
Right.
It just never, well, what causes inflammation? What's that all about?
Yeah.
And then I happened to be introduced to a agroecologist by the name of Dr. Robert Faust, who is a soil scientist, and he was world renowned by that time in 2005 or 6 when I met him. And I started to make the connection between soil biology and soil ecology and my own life through something called fulvic acids, or Wujinzan, which the Chinese know as golden medicine. So that kind of got me connected to inflammation in an unusual way. I had a patient who was athletic, trained every day as well, but he had intractable ulcerative colitis. He was on maximal medical therapy, getting steroid enemas. He was on steroids, oral steroids, having 6 bloody bowel movements a day.
Wow.
And losing weight. He couldn't keep anything down. And so I had studied with Dr. Faust enough to know that the Chinese had been using fulvic substances as rectal irrigation or oral medicine for thousands of years, dating back to the Ming Dynasty. And everything I do, I experiment with myself before I used it on my patients, because I want to know what's going to happen in me, and then I also want to be able to understand it so I can explain it to my patients.
Right.
So I was basically getting ready to experiment with it, but I also knew he needed help. So I filled up I'll never forget this, a San Pellegrino bottle with fulvic acid, which I, by the way, drink every day. I don't know if you can see, not yellow. With that. But anyway, he started drinking Wujinzan, golden medicine, and within 2 weeks, his bloody diarrhea cleared. He was able to start gaining weight, and I got him off the steroids. You know, that was 20 years ago.
Yeah.
So again, okay, so I had the experience with Enter the Zone, nutritional biochemistry, and then now fulvic substances with this, what I consider this miraculous cure.
Right.
Why did this happen? So that then led me on to the next step, which was also introduced to me by a Chinese medicine practitioner colleague. And he was telling me about vortex water. Well, what is this all about? Vortex water. I heard him talk about it, kind of like, well, I was deep into, anti-inflammation and teaching people about eating what I call an insulin-glucagon balance. But again, an experiment. Well, okay, I'll try it. And he forced me in a way into it because he got me this water pipe that I hooked up to my shower.
Yeah.
And I started taking showers with vortex water. And immediately I didn't smell any chlorine. Well, what's this all about? Like, where's the chlorine going?
Right.
And, with experimenting the study, well, when a vortex force is applied to chemicals, then the chloramine basically is breaking apart, and there's no more chloramine in the water, so you can't smell it. But there is chlorine as an atom, and nitrogen as an atom, and hydrogen as an atom. So the other part I noticed is that instead of the water rolling off my skin and not feeling hydrated after a shower, my skin was much softer, and I also felt better.
Yeah.
So this is probably 6 or 7 years after I started to eat biochemically. And so that was the next piece. vortex water supports hydration. Well, how does it do that? And effectively, that led me to another series of articles. I don't know if you've ever heard of Rudolf Steiner, but he wrote an article called "The Heart is Not a Pump."
Mm-hmm.
And what he noticed is that even in the embryo, before the heart starts to beat, the blood is already moving.
Right.
And it's moving through its own inertia.
Mm-hmm.
And that momentum is a vortex action. And it's vortex action that supports all of the systems in the body.
Yeah.
I mean, we are a whirling vortex of atoms.
Right.
Every atom of every molecule of every supermolecule inside of us is whirling in a vortex motion.
Yeah.
And then I was introduced to homeopathy in about 2012 or 13. I don't remember exactly. And that then led me to understand simple basic principles, which I just never even thought about.
Yeah.
But what the human body is a solid piece of matter that's taking in solid food,
Mm-hmm.
converting into liquid, then making it into gases like carbon dioxide,
right,
expelling taking in oxygen as a gas, expelling carbon dioxide, and making water, and then also transforming into the fourth state of matter called plasma.
Right.
What is plasma? It's as you add more force and energy from solid to liquid to gas, you're getting the protons and the electrons separated from each other. And now you've got, in a human body, you've got four states of matter that are existing symbiotically, if you will.
Right.
And this fourth state of matter is pluses and minuses. It's the language that runs us.
Yeah.
So it's really this fourth state of matter is what is controlling the integration of all the systems of who we are. And it's fundamentally also the power that runs us.
Mm-hmm.
That piece of the puzzle came when I was studying homeopathy in Ireland, and I went to, it's called an Electric Universe Conference. I don't know if you ever heard of that or not.
No, I hadn't
Walt
heard of that.
Thornhill and colleagues from Australia, electrical engineers,
Mm-hmm.
who have studied cosmology in terms of also a plasma universe, that everything in the universe is plasma.
Right.
And plasma is it's a separation of charges, pluses and minuses.
Yeah.
And that is the source of electricity. It's electricity that actually runs us.
Right.
But in order to have electricity, we have to have a power source. So we know, especially in the athletic world, we know there's an electron transport chain in the mitochondria that using glucose and FAD and ADD transports electrons to ultimately create ATP,
right,
carbon dioxide, and water.
Yeah.
But what is the system that's actually running the production of ATP in the mitochondria? It's called an electromotive force.
Okay.
And as an electrical engineers know this, and I have a brother who's an electrical mechanical engineer, brother-in-law who's an electrical engineer, so they help me put all this together.
Right.
But there has to be a power source.
Mm-hmm.
And that power source is the sun.
Right.
The sun is emitting wave energy as a power source. However, we know from Edison's work, E equals mc squared, there has to be mass for energy. So there has to be something that translates the energy. So the translator of the energy in the human body is the melanosome.
Okay.
Melanosomes are complex organic structures which have yet to be fully elucidated. But suffice it to say, there's lots of iron in them, and they are pigmented structures that surround the nucleus of every cell. So what this does is surround the nucleus of every cell with iron.
Okay.
And when light hits the melanosomes,
Mm-hmm.
it's generating electric current.
Right.
It's called an induction motor.
Right.
And this electric current then generates an electromagnetic frequency, which then effectively, because it's non-local, it sends out power to all the cells. And from there, then every single biochemical reaction that happens in the body to sustain and support the biomass, which is repairing cells, making new red cells, making new muscle, making new heart cells, making new brain cells, that is supported by the power of electricity, allowing for catabolism, which is taking large molecules and breaking them down into small. Catabolism, release of energy in small steps. It's called concatenation. In small steps that transfer energy from one thing to the next. We didn't have the system in place, then literally, because this is a system that's burning fossil fuel. We are made of fossil fuel and we're burning a fossil fuel.
Right.
And if we didn't have a system that allowed energy to move in small steps, then we would literally burn up. So it's the electricity that's allowing ATP production. It's also supporting the enzymes to work, the activation of energy of enzymes. You know, as a student in medical school in biochemistry, we learned, activations catalyze reactions that would otherwise take hundreds of years to happen. They provide the energy to make the systems run. Well, that was another question, a big question I had in all this. Well, what is the activation energy of the enzyme systems? Well, it's electricity. So the sun's light hits the melanosomes, which are able to split water. What does this mean? So this is something I learned from the electrical engineer. So what does splitting water mean? So effectively, water will store energy from the melanosomes in its hydrogen-oxygen bonds, and it will convert that chemical energy into electricity, which then creates monoatomic hydrogen, monoatomic oxygen, diatomic hydrogen, diatomic oxygen, water vapor, which is the gaseous form of water, and then something called electrically enhanced water or plasma water. Water in the plasma state, which is a high energy state of water. And this is what's controlling the generation and the self-generation and the regeneration of electricity in the body. So without water in our cells everywhere all the time, we can't generate the electricity that we need to run this system. And so back to my medical practice 25 years ago, I was measuring, that was part of what I did with everybody, body composition testing, lean body weight, total body water, and I would say 95% of the patients in my office were dehydrated. So if there isn't water, it's called adsorbed. And this is different from like the absorption of, when sponge takes on water. In an electrical system, this is harder for me to explain, but in an electrical system where proteins and fats and sugars and starches all have a molecular structure, they are made of different elements that are binding or unbinding and creating charge, creating electrical charges. And so the movement of these charges requires water around the proteins, around the fats, around the sugars, around everything in the cell. If we don't have water and there's a lot of research been done by a man named Gerald Pollack out of the University of Washington. He's written a book called The Fourth Phase of Water, and he talks about water structuring, and the water structuring means water separating into charged units, which allows separation of the charges everywhere else and everything else. And this is what allows the language of intracellular communication.
Yeah.
So bottom line is we have to have water everywhere all the time. And it's a loss of power and a loss of water that leads to dis-ease. I mean, fundamentally, dis-ease is a loss of electrical power.
Right.
And then that's layered on a loss of water, which leads to dryness in the cells.
Yeah.
Receptor sites at the cell membrane require a shape that is contingent upon water structuring the sites so that they all work correctly. And when these receptor sites dry out, they don't work. So the other part of the problem is we have to burn fossil fuel to live. We can't make our own food like plants do.
Right.
The longest lived structures in the Earth's history. Starts with bacteria and then fungi and then multi-celled organisms. And then plants who are rooted in the soil, making their own food and living off their own food, but also creating lots of chemicals to protect themselves. Human beings have to get their food from plants or animals that ate the plants. So in doing that, we have to process our food. We are food processors, and processing food generates heat. Heat is a waste product of metabolism. And that wears us out, basically. So how we live well is to find the way that we can provide for our nutrient needs, which are effectively atoms that replace the atoms that we lose. We have to be able to have a system that reduces the food that we eat to atoms and then rearranges them and makes new brain cells or new eye cells or new skin cells or whatever it is. So it's fundamental that we provide the conditions that support electricity, that support our enzyme systems to work properly, and then eat biochemically, so that we are meeting minimal nutrient needs. We're meeting our minimal nutrient needs and spreading the calories out over a longer period of time. So we're getting what I call interstate highway traffic rather than flooding our engine and drowning our engine. And so gets me back to, the inflammation question. Because we talk about it in terms of interleukins and tumor necrosis factor alpha and upregulation of cytokines and all of this stuff. But what does that really mean? Well, inflammation means to burn. If we go to Ayurvedic science and the fundamental earth element, water, air, metal, then we get a more coordinated understanding of what's happening in that if we are burning calories, we are creating inflammation. Because what does that mean? What does a calorie mean? Well, it's the amount of heat that is required to raise the temperature of water 1 degree centigrade. So when we are processing food, we are burning calories. And when we are burning calories, we're generating heat, which wears us out. And the other part of this is that there's, getting back to the electricity, we have two sides to us. We have the heat generating side, which allows for something called dynamic action. Thinking, breathing, walking, talking, sleeping, the physical things that we do are generating heat.
Yeah.
And certainly that's required to live.
Sure.
But we also have an equal and opposite thing that's happening in our body, and that's called implosive action. And that's happening at the center of the cell, the nucleus, which is burning a cool flame. This splitting of water creates implosion energy, which was defined in the 1940s and 50s by a man named Victor Schauberger, who was an Austrian naturalist, sorry. And he just studied water. He studied the movement of water. He built flumes in the Austrian forests to bring the wood down for processing. And he noticed that the fish were actually being moved without them swimming at all. And it was imploding energy from the vortexing action of water. So it's this action of water that's burning a cool flame in the nucleus, which either takes on ultraviolet or reflects it. The nucleus is blue. It's a blue flame.
Yeah.
It's a cool flame. It's where we generate 0 point energy. So in order to have a balanced life, we have to have a balance in both the dynamic action of our body and the implosive action of our body. And that requires water.
Yeah.
And it requires an understanding of the biochemistry of how food is processed. So that we're not either underloading or overloading the system.
Yeah.
Because any too many calories at any given time on our, I call it the blood highway, it's requiring too much burning, too much heat.
Yeah.
And by the same token, if we're not presenting to our body a fuel that it can use, whether it's glucose, whether it's amino acids through that produce glucose through the gluconeogenic process, or the fatty acids that are burned in the mitochondria, then we end up having to burn calories that we've stored.
Yeah.
And that leads to more need for energy and more burning of calories. So the way I see it, optimal health is kind of getting a blood sugar that's close to what's called euglycemia, a blood sugar that's just right, not too high and not too low, because what's going to happen is if you don't control blood sugar, if you're eating chaotically, then your body is going to have to do the work to bring the blood sugar down or to bring it back up. And that generates a lot of heat. Yeah. It's energy expending. So how do we find that balance? And I go back to what I've learned over the years. And also go back to, in the course of the 25 years of my, what I call now foundational medicine practice, I probably could count on one hand the number of people who actually knew how many calories they were eating every day.
Right. Yeah.
Now, many of your athletes, I'm sure, do.
Yeah.
But most people have no idea how many
yeah.
calories they're eating every day.
Yeah.
And that makes a difference.
Yeah.
Calories do matter.
Right.
There are a lot of people out there who say calories don't matter as long as you're burning as many calories as you take in.
Right.
Well, when you're burning the calories that you take in, you're creating heat.
Yeah.
So for optimal health, figure out how many calories you need to sustain and support whatever your life is.
Right.
It could be you at the elite athlete level.
Right.
Or it could be somebody who's sitting at their desk all day doing computer work.
Yeah.
So everybody has to figure out how many calories they need every day, and then understand that each food group, carbohydrates, proteins, and fats, also is serving an essential nutrient needs.
Right.
Carbohydrates are essential nutrients.
Yep.
Proteins are essential nutrients. Fats are essential nutrients. We need glucose.
Right.
It's the primary molecule that's delivered into the cell that is generating ATP.
Right.
Glycolysis starts in the it's called the cytoplasm in the middle of the cell, but it moves on into the mitochondria to then produce ATP. If you're not providing glucose to your glucose to your cell, and instead you're requiring glucose to be produced from breaking down your own muscle protein or breaking down either your fat stores or burning ketones, how much energy is expended when you have to, go back and forth to through the gluconeogenic process, create sugar, or through the breakdown of triacylglycerols to deliver sugar into your cells.
Right.
And so we have to look at the energy burn.
Yeah.
So that's what I've taught my patients for 25. Figure out how much you need, figure out how much protein, how much carbohydrate and fat you need. And technically, a balanced diet biochemically is equal calories from protein, carbohydrate, and fat every time you eat.
Right.
So it's not about fasting, but it's about calorie restriction every time you eat, and then eating at specific intervals that are going to supply you the minimal amount that you need to sustain and support the needs that you have for carbon, hydrogen, oxygen, nitrogen, sulfur, magnesium, etc., the elements that your body will then use to make new cells. Because living requires tissue renewal. It requires new cells to be made all the time. And we cannot be doing things, I call it the wheels turning. We cannot be doing anabolic work, going and being and doing and processing and repairing and recycling at the same time. We cannot be doing equal and opposites at the same time. So ultimately, we have to figure this out.
Right.
And there are many different ways to do it, I suppose. But Dr. Sears, 25 years ago, when he wrote this book, he worked with Stanford, the Stanford swim team, and some football team, I can't remember the name. But he did immersion testing for dunk take, body fat, resting energy expenditure, VO2 max studies, and then plotted out how much protein, how much carbohydrate, how much fat a person needs based on their activity level. And more or less, the protein was set by lean weight because we don't need to fuel our body fat. Our body fat is there to feed us. So the protein needs is set by our lean weight, which you get by the biometric testing, and how active we are. And then that sets our need for carbohydrate calories and fat calories. And then that allows us to expand or contract. One day you're more active because you're training for your marathons or whatever. Another day you're on an airplane going somewhere. So this understanding the biochemistry allows you to expand or contract depending on your activity level for that day. And then you're not overeating or undereating. Because to me, the diet culture that's out there, it's just giving people license. Well, don't eat any carbohydrates. And you can eat all the fat and the protein that you want. Don't eat any fat. And you can eat all the carbohydrates that you want. Just eat raw. And there's no consideration that the nutrient extraction depends how much nutrients we get from the food that we're eating depend on the metabolic processes that are going on inside of us relative to the flow of electricity, the flow of water, and the enzyme systems that we have in place. And enzymes are very particular. Enzymes work in a very narrow range of pH.
Okay. Yep.
They depend on substrate concentration, which means how much stuff is presented to them at any given time. They work based on temperature.
Yeah.
And they work on salt concentration. So if we're overwhelming just as an example, if we're eating too many calories of protein or carbohydrate or fat at any given time, it's too much calories for our enzyme systems to handle. That's too much substrate. So what is going to happen? We have something else in our body that's functional, a microbiome and a mycobiome that have the ability to metabolize food. They need food too to live.
Right.
What's going to happen is the microbiome, which includes fungi and bacteria, will ferment the excess food that we're eating. And what are the fermentation byproducts of bacterial and fungal metabolism? Acids, lactic acid, uric acid, phenolic acid, acetic acid, glutamic acid, which are then recirculated through what's called the portal circulation. That means delivered to the liver, which is dependent for its metabolism on the delivery of blood into these things called sinusoids or lakes. Blood needs to be a pH of about 7.3 to work.
Right.
So what happens when you're delivering a pH of 7.2 or 7.1 or 7.0, because you're flooding your liver with acids from the fermentation of your food because you've eaten too much, your liver doesn't work correctly.
Right.
And that's something that isn't also understood. There's a lot of discussion about healthy microbiomes, but what about the pH chemistry of a stomach that has to work at a pH of 6.5 to make hydrochloric acid that's a pH of 2? So what happens when you put vinegar in your stomach? You're drinking lemon, your citric acid, lemon or lime water, or you're drinking vinegar to slow down the process of digestion. What happens to your ability to make hydrochloric acid when you're drinking vinegar? Your stomach can't work at a pH of 2. So the way it works is you put a mixed meal in to your stomach that keeps it around a pH of 5, 5.5, 6, 6.5, so that it can produce the hydrochloric acid that then facilitates protein digestion. It then supports the neutralization of the alkaline amylase and lipase that comes from the pancreas to deliver into the intestinal tract a pH of about 7 in what's called the lumen in the opening, in order for the intestinal epithelial cells to work properly. If you're breaking the pH rules of what you put in your stomach, then you don't get proper neutralization of the digestive juices from the pancreas, and you get over-acidification in your intestinal tract, the upper intestines. And what does that lead to? Leaky gut and SIBO, small intestinal bacterial overgrowth. So these first principles or foundational principles have to be followed, or otherwise there's disease. There's just no way there won't be. And in my understanding, in my study, the body has an unlimited capacity to take on whatever we want to stress it with. But it doesn't really have an unlimited capacity to deal with the consequences. And it's confusing. I still haven't figured out exactly why the body's designed like this. But it's not until about 80% of what I call functional reserve or resilience is lost until we recognize something's wrong. So it's about 7 doubling times, which is in a human body of all the cells about 7 years. So it's not until 49 years of age that breast cancers develop, for instance, or colon cancers or heart disease. It takes about 75% occlusion of an artery before there's anything noticed that's wrong. And the truth is that artery was getting occluded for many, many, many
For
years
yeah.
before it became an obstruction.
Right.
And the same with, with Alzheimer's disease as an example.
Yeah.
The seeds of Alzheimer's disease are starting at 26 years old.
Yeah.
When we start to lose our ability to translate the sun's energy through the melanosomes into water. So from 26 years old, we are losing the capacity to support energy, and day by day by day, we're losing resilience. What does that mean to me? It means our cells are dying faster than they're getting replaced. Our body is drying out because we're losing water in this process of processing our food.
Yeah.
And the brain is 70% water.
Right.
If we looked at our brain on a infrared scan, it's lit up. I mean, we look at the world maps, and we can see city centers because it's red and orange. Populations give off infrared, and our brain literally, when it's processing, is on fire.
Yeah.
And what contains the heat in the brain? It's water.
Right.
Water, the brain is 70% water by weight. And when the brain dries out, then cells are being lost.
Right.
And the problem is, once that cell is dried out, there's no water there. Then the lysosomal function, which some people have heard the word autophagy, the lysosomes in the cells are our trash composting system and waste disposal system in the cell. Well, if the cell is dried out, it can't dispose of the waste because it has to have electricity to dispose of the waste. And so now we've got this little cell in our brain that's dried out, that's not communicating with any other cell, because the communication has to happen by the movement of electricity.
Right.
And, little by little by little by little, I call it the light brights, if anybody's familiar with that old the light bright toy.
Yeah.
Little by little, the lights start to go out. And once we've lost power to a cell, it's very hard to restore it, because now that organic matter, and the brain is made mostly of fat and sugar. What happens when you heat sugar?
Yeah.
It goes from a soft ball to a hard crack stage. It's brittle. Brain of Alzheimer's disease is at hard crack stage. It's hard like a rock.
Yeah.
And it's very hard to put water into a brick.
Yeah.
To make it back into mud.
Right.
And that's why we don't have any medications that work for advanced Alzheimer's disease. The time to address Alzheimer's disease is now by supporting the water element of our body with vortex flow, so that our water is moving like a cement mixer.
Right.
Keeping what's in it mixed. The proteins, the fats, the starches, the sugars, the lipoproteins, etc., are being mixed with a vortex action and taken to where they need to go, and water is supporting the intracellular the functions inside the cell, which are allowing the movement of everything that happens inside, the generation of ATP, which is an important energy coupling thing. It's hard for me to describe it, but it's an energy. It contains energy and then transfers it to the next thing. So it's an energy coupling device.
Right.
But we have to have water for all this to happen. ATP doesn't even the terminal phosphate, it's called, the phosphorus doesn't even get released without hydrolysis. There's a hydrolytic enzyme that's required to break the terminal phosphorus from ATP to create ADP. And the activation energy to make the phosphorus fall off is actually more than the energy is released. So it's then instead of losing entropy, we have to have the opposite reaction that's reversing that, and that's the blue flame that's happening in the nucleus from the splitting of water going back to the sun.
Right.
So all of this is a lot of, talk to my family about this and they say, well, can't you just put it into words that people
Right.
can
Yeah.
understand?
Well, and it's tough, and it's because there's so many different systems at work at
Correct.
the same time. And if one thing gets out of whack, then okay, the other systems may work for a little bit, but they're like, you better catch on, you better come back, and if you don't, like, then other things are going to start to fall
Correct.
apart. And like you said, it's not necessarily, it immediately going to show up as a symptom or, especially if it's something chronic or something long term developed like
Right.
cancer or Alzheimer's. You may not know that you've got a broken wheel in the in the system
Yeah.
until, and then and like you said, it's like if you go through a huge drought for a long time, and I live in Texas, and a couple of years ago we went through a massive drought for a really long time.
Right.
The ground dried up, cracks everywhere, and then we got a big rainfall and it floods everywhere, and everybody's going, "Why didn't the ground just soak it up? It's dry. It can't.
Right. Exactly.
It's
Right.
just going to run off." What you need is a really light rain to just soak in and soak in and soak in over time,
Correct.
and the cells don't necessarily work that way because yeah, once they dried up, and you said something that to me was like, okay, that unlocked something for me in my brain, and the different things that I've heard and read, and to me it sort of relates to, because my wife has said this, other people in my family have said this, like, I don't feel well, but my blood test results are fine, so why
Right.
can't you
Right.
help, right?
Right.
And
Right.
when you said that when the receptors can't receive because the cells don't have water because they start to change shape and they can't
Correct.
receive things as well, it's like
Correct.
the blood may show you that everything is correct because what's in the blood is normal levels of these vitamins, and
Correct.
but if it can't actually get absorbed or communicated,
Right.
then that's going to be a stopping point, right, in that chain, and that's going to show you somewhere down the line, like, okay, now I don't feel well.
Right, exactly, because there's so much redundancy that's built in the system. So when we're fully mature adults, we have about 70 trillion cells in
Yeah.
our body. And we can create normal blood testing
Right.
if we have 70 trillion cells or 60 trillion cells or 50 trillion cells. But once we have about 80% of those cells lost,
Yeah.
that's when the blood testing changes.
Right.
You can have normal insulin levels, you can have normal vitamin levels, you can have normal A1C, you can have normal uh, electrolytes, you could have normal cortisols. But what is your body having to do behind the scenes
Right.
to produce that?
Yeah.
And if there isn't attention being paid, like I said, if there's eating chaotically, your body, and just like you described, your body's having to make adjustments because if
Yeah.
something happens over here, the body has to adjust over there, and then it has to adjust over there, and you're playing this whack-a-mole game all day
Right.
long, and that takes energy.
Yeah.
So if we're not energy efficient in our daily lives, we're losing redundancy, we're losing resilience, and that's the confounding thing. I
Yeah.
don't know how many patients told me, I'm 50 years old. I used to eat all the M&Ms that I would like, and now all of a
Yeah.
sudden I'm getting fat.
Yeah.
So it's confusing. I mean,
Yeah.
even kids who are 5 years old and 6 years old, drinking soda and eating candy and ice
Yeah.
cream, and they're thin.
Yeah.
So they're okay
Right.
because but the resilience is being lost a lot sooner now in our
Right.
modern world.
Yeah.
Kids who are 10, 11, 12 years old are diabetic.
Mhm. Yeah.
Kids who are 13, 14, 15 are suicidal.
Yeah.
They don't have energy. And it started, 20 years ago when ADD, ADHD, all of a
Right.
sudden everybody, including kids, has a chemical imbalance. So we're going to give a drug to alter the chemical balance when
Yeah.
we weren't looking at what was causing that chemical imbalance in the first place.
Hmm.
And it's the food we eat and what we have to do to process that food or not be able to process that food that creates who we are, what we look like, and how we work.
Yeah.
It's pretty simple. We can get lost in all the details.
Yeah.
Which is a medical student and then a resident and student of all these different things, it's kind of you can get lost in the details.
Oh yeah.
But that's, I guess that goes to back to my chemistry background. If I could understand if I could go back to first principles, go back to source, then I could know that A is going to create B, C, D, E, and F and get all the way to Z. I never really was very good for memorizing things.
Yeah.
But if I know that my body is dependent on electricity to function, and that electricity is created and supported by vortex water, and that I'm a hydroelectric plant, then I can drink half my body weight in ounces of water per day, vortex water per day, and usually more. Usually I drink about 3/4 of my body weight. So even if people just started there, drinking only water, and there's confounding things there too. Well, if you're drinking tea, or if you're drinking smoothies, or if you're drinking whatever lemon water, you're drinking whatever kinds of beverages are out there, you're getting water. Well, no, you're not getting water, because within coffee and tea and smoothies, there are chemicals in there. It's food that has to be reduced to atoms. And the water that you get in tea and coffee is not in your cells. You need water in your cells to do the work when that food is presented to your intestinal tract. So it's drinking only water and not drinking things that dehydrate you. Coffee is one of them. Alcohol is another one. Tea is another one of them. Soda's another one. Drinking only water. And a lot of people don't like to hear that. I've got to have my coffee every day. There's all sorts of people that are touting all the benefits of drinking coffee. But fundamentally, it's dehydrating. It's 1,000 different chemicals in coffee, 800 of which are volatile organic chemicals: benzene, octane, butane. That gives the smell to coffee. But also in coffee, there are 24 different chemicals, including neochlorogenic acid, chlorogenic acid, that when given in high doses to lab rats, cause cancer. And this is from work that was done by Bruce Ames. He was the head of the Department of Nutritional Biochemistry at UCal Berkeley. I mean, he wrote this in the 70s. Somehow we've kind of lost touch with these basic principles, but everything is chemicals. And the primary exposure that we have to chemicals every day is the food we eat. Certainly glyphosate is a chemical we can't handle. But food is also chemicals. We have to be able to take the food we eat and reduce it to atoms. And if we can't do that, then we've got a bunch of garbage in our system that we can't get rid of. So if we just start simply drinking vortex water, and then using what Mother Nature gave us, and this is whole nother topic, but using what Mother Nature gave us 2.4 billion years ago, which allowed the creation of organic life on this planet. What does organic life mean? It means something that has carbon in it. So fungi were able to take rock, which is inorganic matter, and it's called fixing the carbon dioxide and the water, were able to eat the rock and produce something called fulvic acids, which the Chinese again knew as golden medicine. They are structures, they're complex structures, which, just like melanosomes, have been very hard to identify, because once you try to identify it, you've split it up and you can't really assess its full action. But it's effectively carbon, hydrogen, oxygen, and nitrogen, specifically very high in hydrogen and oxygen, which is primarily what we have to balance all this chemistry that we're doing. Hydrogen as protons People know this as hydrogen water, quote unquote. Hydrogen
Sure.
is protons, electrons, and all these things have to move around, and it's primarily water and
Yeah.
fulvic acids that are responsible for pH balance without the need for food.
Yeah.
So water is the primary regulator of acid-base chemistry. It's the primary hydrogen donor. It's
Yeah.
water that is, as Albert Szent-Györgyi said years ago, water is life's matrix, it's life mother and life's medium.
Yeah.
And like you said, nothing works without water.
Yeah.
And what happens, getting back to your example of the water, if you get too much water in Texas on top of soil that's dried out,
Yeah.
why does that soil not absorb water? Because the soil also contains salts.
Right.
So once the soil dries out, the salts come to the surface and they are dehydrating. Effectively, they've taken the water out of the soil, and now you get, it's called black alkali on the top of the soil. And when the rain comes, the water will not penetrate the the dry soil.
Right.
And that happens in our body too.
Mhm.
Going back to what's controlling enzymes, salts and salt concentration affects enzyme production. So if we are drying our cells out, we literally get crystalline formation of salts,
Right.
which are not just salts of minerals, but they can also be salts of acids.
Yeah.
Then we get this layer of black alkali
Mhm.
on our cells that
Yeah.
doesn't allow any water that's coming in to get into the cells. So we drink a lot of water, but then we just pee it out.
Yeah.
We just urinate it out because we have to have balance in our blood of things that are traveling there. Otherwise, our brain dies.
Yeah.
So we from my perspective, I just get people back to first principles.
Mhm.
And then what happens when you get the electricity right, when you get the flow right, when you get the balance of pH chemistry right,
Right.
then the body takes over its function.
Yeah.
Uh, a lot of which is supplemented today is actually something that's recycled in the body.
Right.
Minerals are needed in trace amounts and they're actually recycled in the system. Um, so the body takes care of itself,
Right.
and there's not a lot of need for micromanagement, because the
Right.
truth is we cannot micromanage this process. Hundreds of thousands of different enzyme systems running hundreds of thousands of different
Yeah.
chemical reactions, and we have to keep the body clear
Yeah.
in its ability to communicate.
Mhm.
And that communication is the binary language of plasma.
Yeah.
And that plasma is a separation of pluses and minuses, a separation protons and electrons.
Right.
And if we got it too much jumbled up, our body just can't work efficiently, and it's
Yeah.
going to wear out.
Right.
So,
Yeah. Because it's constantly trying to figure out, what am I supposed to do?
correct. And what can I do? What
Right.
what do I have the capacity to do? And sometimes it says, I just can't do this. I want to do this, but I'm being blocked by something. I don't have flow. I don't have electricity. I need power.
Right.
So most disease is associated with a loss of energy, a
Yeah.
loss of power.
Right.
And the power is generated by electricity. Yes, ATP is an important energy carrier,
Mhm.
but ATP itself doesn't generate electricity.
Right.
It generates something called Gibbs free energy. So it's an important mover. Phosphorylation reactions are important actions in the cells that allows everything to work.
Right.
But it's water. Even if we looked at the generation of the proton gradient in the ATP in the mitochondrial inner mitochondrial membranes, it's a continuous supply of water
Yeah.
that's being broken apart into protons it's called a hydroxyl radical, the negative charge, the OH negatively charged part of water. And that's the driving force that's driving the electron transport chain. I'm oversimplifying a little bit, but I'm trying to get the big picture.
Right. No, and like so many of these things, like you've taken what I've tried to explain to people about, like, oh, you want your pH to be this and you want this, and this is how, because, and I've told this to several people, including, I have two clients that I help on a health coaching standpoint, and they're both doctors, and they're trying to lose weight to obviously be able to function better. And I'm like, okay, well, you're not eating to get your pH correct to where your stomach can then go into your intestines and everything goes, because yeah, if your pH is too low going into the intestines, it's like you said, leaky gut. There's other things. It's just, it doesn't know what to do. And so you're either going to get constipation or you're going to get really just diarrhea, and just because your intestine goes, I can't deal with this, and so I'm just getting rid of it.
Right. Exactly.
And and so it's like, okay, well, how do you balance that? And you can do it without going to antacids or other things. Like, it's looking back at what food am I eating, what am I putting in my body that's then triggering these downstream systems.
Right, because pH 2 cannot be micromanaged.
Right.
We have to bring the food in, honoring that each system works at a different pH. The stomach at a pH of 6.5. The duodenum starts to get more alkaline, a pH of about 8. It reaches the small intestine, a pH of about 7. Then it gets to the colon, it's slightly acidic, 6.5, because that's when the bacteria are starting to ferment. And the bladder has to be a pH of 6.5. The mouth, a pH of about 6.5 too. The skin, a pH of 6.5. But the blood, a pH of 7.3, 7.4, just like the cerebrospinal fluid. So every organ system works at a pH that's specific to its function. And the way that happens, so that all the organs are working at the pH at which they're supposed to work, is by starting with bringing food into the stomach that sets up the conditions for the stomach to work properly. And that's a mixed meal of what you need: proteins, carbohydrates, and fats every time you eat. And in such a way that you're not overloading the system. And then not going so far between meals. And this is something people don't understand about intermittent fasting. In my experience with it, and my patients talking about it, well, I can just eat whatever I want to eat for 6 hours or 7 or 8 hours a day, and then just fast for the next 18 or 17 or whatever hours a day. They don't understand that their brain needs a continuous supply of glucose. And so do the red cells. The red cells do not have mitochondria. The red cells have to have glucose to function. And what's happening during these long periods of fasting is the body is breaking down its own muscle. That's where it's going to go first, to be made into sugar, glucose, to fuel the brain and to fuel the red cells. And when protein is broken down, it's the more acidic proteins that are broken down to create glucose. So the blood, while it's breaking down protein, and then eventually, some fat, and even the metabolism, beta hydroxybutyrate and fatty acids, is acidic. So for that period of time, when your body's fasting, it's cannibalizing its own self and creating acidity in the bloodstream. And once you lose the pH balance in your blood, what happens to that cement mixer? The blood is no longer being mixed properly. Because pH is also equivalent to electricity. So once you lose the electricity, what's happening to all these things that are in your blood? They're literally, the chemical term is they're falling out of solution. And they will land on the back of your artery, and then when you're laying down, it'll be the back of the arteries, your main aorta, the arteries to your legs, your carotid arteries, or these calcifications are in the dependent parts, lower back, the back of your arteries. And once that organic matter, proteins, carbohydrates, is now on your arterial wall, it's going to sit there like a splinter,
right,
and it's going to create a wound.
Yeah.
So it's going to break down the artery, and it's because you've broken the pH rules.
right,
You've lost power in your bloodstream.
Yeah.
And now your blood is more acidotic. And it doesn't have to be a huge change. It doesn't have to be a pH of 6.7, which is incompatible life, but it could be a pH of 7.1 or 7.0. Just for that moment, resilience is being lost. And it's an important part of this process.
Yeah.
So for me, in this diet culture, I think generally people want to be healthy, but they don't know how. Just like me when I was younger, and carbo loading, because that's what I was told to do.
Right.
I was, like I said, hungry all the time and tired all the time.
Yeah.
And my body fat wasn't changing. And nutrition is a science. It's not a diet plan.
Right.
And if you are in the mindset of a diet, you're already in excess.
Yeah.
And it's a loss of power, and it's overload, it's excess that is what is the splinter in the wound, that is the disease under the ocean. That's the iceberg starting to form, that ultimately becomes the breast cancer or the colon cancer or the Alzheimer's disease or the ulcerative colitis or the diabetes. It's inefficiency in the system. Another way I say this, we have to get to a place of lean manufacturing, that we're delivering things. This is what my vision. I see all these different organ systems that are factories, and we've got all these pieces of machinery on the factory floor. We've got the superintendents in place. We've got the computer programs running. And what we need is for things to come in smoothly, for the conveyor belts to move smoothly, to take in the nutrients, to process the nutrients, to make the cars and get rid of the garbage that we've made in making the cars, because we're not using all the spinach to create red cells. We have to take the spinach and turn it into a red cell. And in that process, we make waste, which is not just stool that comes out, but it's also metabolic waste that has to be handled under proper conditions of pH. And when the pH drops inside the cell, then the cell cannot function properly.
Right. Well, I want to be respectful of your time. This has been, like, super educational and great information. How can people connect with you, follow along with what you're doing?
Well, I have two websites. One is my own medical practice site. It's wanekmedical.com, WANEK medical.com, all spelled out. And at that site, there's more information about the different elements of our body, the air element, the water element, the wood element, the fire element. And then I've written a lot of different articles that go into what I've been talking about in greater detail, and that's in my blog section. And I kind of laid it out into a history of the human being, and kind of even going back to the history when we have the first written tablets. Human beings have actually never been healthy because we haven't really ever completely understood these things that I'm talking about. And there's, we are living I'm not meaning to say and be critical of anyone's life. We all have a life to live. It just depends on what we want. And what I'm trying to bring to the fore is information, more information that people can live a life in a different way if that's what they want. So the other website is called liveamanalife.com, liveamanalife.com. So the invitation there is to live a life filled with mana. Mana means energy. Mana comes from the sun. So that's more about connecting the sun to water, and then fulvic acids or wujensan, which Mother Nature gave us, again, 2.4 billion years ago.
Right.
And there's a difference between fulvic acids that Mother Nature made and fulvic acids that are made in a lab through manipulating acid-base chemistry to create salts.
Right.
And we're the only company, at least in the US market, and for the most part, except for the Chinese market, because they have perfected the technology of producing fulvic acids at scale, even using it IV and intrathecally, I mean, into the cerebral spinal fluid or rectal irrigations. They've been using this for years. They perfected the techniques. There are no other companies on the US market that are creating fulvic acids the way Mother Nature does.
Right.
And what's being sold are salts, which create this alkaline soil that we're talking about, the black alkali that actually takes water out of the cells and makes a hard membrane. So yes, people can go to liveamonalife.com to learn more about Vortex water and Wujinsan.
Yeah. Well, and to the salt thing, like one of the things that as an athlete, especially an endurance athlete in Texas, that like, you know, there's often summers where I'm running just because of schedule and whatever, that I will run, you know, anywhere from 6 to 10 miles in the heat of the day, just because that's the only time I've got to be able to do it. And people always ask me, one, about hydration, two, about my energy, and three, about like, okay, well, what kind of electrolytes do you take? What salt do you take? How do you? And I don't add any extra salt to anything, because I look at the nutrient standpoint and I'm like, okay, I need magnesium, calcium, right? It's not just salt. And and people are always astonished, and I'm like, but my sweat's not salty. Like the salty sweat in my mind, and maybe I'm wrong, but the salty sweat in my mind is your body saying, I've got too much, I'm trying to get rid of it.
Right.
Because
so just out of curiosity, how did you come to this place where you don't take any salt? I'm just curious.
Well, I mean, just researching a couple different things, and this was years ago, so I couldn't tell you exactly where I saw it. And so it sort of, like you said, I experimented on myself. And every time I go get blood work done, the salt is in, you know, normal range. I've never had an issue with it. And it, at one point I had a lot of muscle cramps, and I thought, okay, maybe I'm not getting enough salt. And it turned out I wasn't getting enough calcium. I increased my calcium, and muscle cramps have gone. And so I'm like, you know, but that's for me. Right.
So, but you're right. I mean, if you have salty sweat, your body is getting rid of what it doesn't need.
Right.
If we look at the history of salt traded like gold. Why? Because it's a preservative.
Right.
It's what allowed nomadic cultures to have food for their travels.
Yeah.
Salt takes water out of meat, and it will do the same thing in the human body.
Yeah.
Because for the most part, the only intracellular ion, and that's different from salt. An ion means a mineral with a charge. A salt is a mineral that's connected to some, like a sulfate or a carbonate or a chloride, or a salt is literally a solid particle.
Yeah.
But an ion means there's a charge to the mineral.
Yeah.
The main intracellular ion is potassium. But it's the body's systems that are regulating where minerals are going to be based on water and the structuring of water. And sodium is primarily an element in the blood. Sodium, chlorine, bicarbonate. It's an extracellular, or in the blood. It's in the blood element. So when you're taking salt externally, you're getting a load of sodium, potassium, magnesium now into the blood that is causing water to come out of your cells to balance what's called osmolality and osmolarity, so that the brain doesn't die this way.
Right.
So the way that minerals are supposed to come into the body is in what's called organic form or chelated form, meaning surrounded by carbon, hydrogen, oxygen, nitrogen. It's minerals come into your body in the food you eat.
Right.
They cannot be micromanaged.
Right.
And the other thing about electrolytes, they don't have to be salts. A major electrolyte in our body are the acids.
Yeah.
Especially in the Krebs cycle, citric acid, fumaric acid, succinic acid, lactic acid. These organic acids in our body are also electrolytes. What does that mean? Effectively, electrolytes are donating or receiving protons, donating or receiving electrons. So it's anything that has the capacity to move charge, to move electricity. And it's primarily the acids in our body, in the Krebs cycle and otherwise, that are managing pH and salt concentration and all that.
Yeah.
And that's why the fulvic acids, I recommend for any athlete, the nature's electrolyte is fulvic acid. So you might want to look into that.
Yeah.
I could, in fact, if you're interested, I'll send you an article.
Yeah.
Talks about fulvic substances as nature's electrolyte because it contains the components of the organic acids that are running our system, as well as organically bound minerals in a broad spectrum form that isn't trying to micromanage it. It's what nature gave us. Yeah. So I recommend for all my athletes that they should be drinking fulvic acids, supplementing with it because it's deficient in nature. Sure. There's plenty of minerals in the soil, but what's gone are the fulvic substances because we've lost the life in the soil, the mycobiome, primarily the fungal element in the soil, and that can't sustain and support the fulvic acids that are needed to take the inorganic matter and bring it into the plant. So fulvic acids are nature's electrolyte. And so while a person is exercising and in post-recovery and throughout the day, fulvic acid is the best electrolyte. Yeah. And I don't recommend that salt be put on your food. Nope. Or that salt is, that you don't drink salt water. Yep. Salt is used in your food as you're cooking it. You put salt in the water to raise the temperature of water. Right. So that the food is cooking a little bit hotter. It allows food to cook more fully. Right. Salt is not a seasoning agent. Right. But salt is facilitating the cooking process. Yeah. It can also, however, act as a preservative. That's why it's in foods that are in bags and boxes, so it extends the shelf life. Right. But I think there is a lot of misunderstanding about salt and water balance in the body. Yeah,
yeah. No, I agree, and I've used that analogy many times with people about the salt being a preservative in ancient times, and it's like, I'm not trying to preserve. I want to regenerate everything. I want to allow my body to keep regenerating because if I preserve cells that aren't working anymore, why would I want to do that?
Yeah, exactly. Right? Because when you preserve your cells, you're drying them out.
Yeah, and it's and that's what I think one of the big reasons why when people look at me, especially when I go grocery shopping, I get this a lot. They'll see what's in my cart, or they'll see that my shirt says health and wellness, and can I ask you a question real quick? Or okay, well, how old are you? You look like you're 35, and I'm like, nope, 51. And I'm like, and it's because I think my skin looks better, and it's not quote preserved. Right. It's healthy and hydrated. Exactly.
Yeah, because the hydration is coming from inside. Yeah. And not something you put on the outside of your body that effectively forms a wax layer, which will eliminate the wrinkles, but that's not bringing the water to your cells.
Right. So, and I feel like we could probably talk for hours. You're a wealth of information. It's great, but I want to thank you so much for being a guest.
Well, you're so welcome. I've enjoyed spending this time with you.
Thanks for checking out the Confidence Through Health podcast. Please subscribe, post a review, share this episode with those you love who need a little extra help with their health journey. Visit allinhealthandwellness.com to learn more about the coaching programs that I provide. All episodes are produced by the Social Media Cowboys, your source for all online marketing needs. Go to socialmediacowboys.com for more information.